NASA astronauts Sunita Williams and Butch Wilmore have returned to Earth after a 9-month stay at the ISS. Their SpaceX Dragon spacecraft undocked on March 19th, and the crew, including Nick Hague and Alexander Gorbunov, splashed down off Florida's coast. Williams and Wilmore had planned a week-long stay but were stranded since June last year after arriving aboard Boeing's Starliner. So, let's explore, how do astronauts return to Earth? Actually, the return of space capsules carrying astronauts to Earth is a meticulously planned process involving multiple critical stages. Here's a step-by-step breakdown of how it happens. Deorbit burn, re-entry initiation. The spacecraft has to first stop orbiting the Earth and slow down enough to be pulled back by Earth's gravity. It does so by firing the spacecraft's thrusters in the opposite direction of travel. The capsule reduces its speed just enough to begin descending toward Earth. It also has to ensure precise timing and trajectory to target the designated landing zone. Capsule separation. If the spacecraft has multiple modules, like service module and crew module, unnecessary sections are jettisoned. The service module, which contains fuel tanks and power systems, is discarded as it is no longer needed. Only the crew module, carrying the astronauts, continues its journey toward Earth. Atmospheric re-entry. As a spacecraft hurtles toward Earth, it carries immense kinetic energy. When it enters the atmosphere, friction with air molecules creates drag, slowing it down. This friction converts kinetic energy into intense heat, which the spacecraft must withstand during re-entry. The spacecraft collides with atmospheric particles, generating intense heat. A heat shield absorbs and dissipates the heat, often through a process called ablation, burning away in layers. Astronauts experience high G-forces, sometimes up to 4 to 5 times Earth's gravity. Parachute deployment. Once the capsule slows down significantly in the lower atmosphere, a series of parachutes deployed to further reduce its speed. The practice is to first deploy the drogue chutes to stabilize the capsule, which ejects when the vehicle's velocity falls below about 2,300 feet per second. The main parachutes then deploy next, significantly slowing the descent for a safe landing. Splashdown or landing. The speed of descent is still not slow enough to ensure a soft landing. The capsule can't simply crash onto a hard surface. It needs a softer landing. Researchers figured out that water serves as a natural shock absorber, leading to the concept of splashdown, where capsules safely land in the ocean. Depending on the mission, the capsule lands either in the ocean or on solid ground. Ocean splashdown, used by NASA's Apollo missions, SpaceX's Crew Dragon, and Boeing's Starliner. The capsule lands in a pre-designated ocean area and is recovered by ships. Ground landing, used by Russia's Soyuz capsules, which deploy retro-rockets just before touchdown to soften impact on land. Crew recovery. Once landed, rescue teams quickly retrieve the astronauts. Navy or Coast Guard vessels recover ocean-landed capsules. Divers secure the capsule and assist astronauts out. Helicopters and ground crews assist with land landings, ensuring astronaut safety.